Hello, I'm Josephina Kalembe and I'm going to be pitching our product, the Conceive Score. So, this is the video demo of it. So, we go to the problem statement. So, the real world problem here is the uncertainty in knowing the best time to conceive. And the people who experience this the most are women trying to conceive alongside the fertility counselors and clinicians. So, why is AI needed? So AI can learn from patterns in hormone levels and cycle data. Because simple automation is just not enough, then a measurable impact is our system reduces stress, improves planning, and supports clinical decisions. So our users, stakeholders, and ecosystem actors, the primary users, are the women trying to track their fertility, the clinicians who usually rely on accurate cycle level predictions to guide reproductive decisions. So then our secondary stakeholders are the hospitals, fertility clinics, and health ministries. Then the ecosystem roles, labs and wearables provided the data, and then fertility apps use our API. Then the governance entities, ethics boards, and regulators ensure fairness and data privacy. Then the data sources and value. Our system uses tabular data and hormonal lab results. Then the data types, the data sources had open data sets from mainly data. Then the processing pipeline is that we join the different data sets from mainly, harmonize them into cycle index tables, imputed the data, and then engineered mechanistic features, and from those mechanistic features we're able to build causal graph relationships. And then the ethical legal framework, all data is anonymized and is privacy preserving, and It follows the Uganda's Personal Data Protection Act. Then the value mechanism is the data powers personalized fertility predictions and supports clinical decisions. Then the solutions and AI system description. Our AI system uses a hybrid stacking method, and the models include the the light GBM, the light gradient boosting machine for interpretable predictions, the temporal transformer for cycle level dynamics, and the relational graph embeddings to encode domain knowledge and regularize prediction. So our model inputs were the cycle-indexed mechanistic features like ovulatory competence, time precision, and symptom patterns. Then the output was the per cycle probability of conception. Then how does the AI generate decisions? The model learned from historical patterns and biological relationships. Then how did it integrate? How does it integrate user workflows? The system is deployed via an API backend and is connected to a responsive web front end. Then the responsible AI mechanism is that we enforce monotonicity, conducted fairness audits, and these ensured compliance and interpretability plus fairness. Then the key metrics and evaluation. The technical metrics were accuracy, F1 score, latency, and error rate. These ensured performance reliability and efficiency in real-world conditions. Then the user-centric metrics is we monitor the adoption rate of the system, then the session duration, and customer care satisfaction. Um, then the ethical metrics, we ran fairness audits for the different demographic parities, and then bias mitigation. And then for the business metrics, we looked at the customer acquisition cost, the lifetime value, and the return of the AI investment. Then the unfair advantage and differentiation. What makes us different? The unique edge, we built a special features and graph-based model that people may not easily replicate. Then our model learns from user feedback this helps to improve prediction and fairness. Then the long-term differentiation is that our system combines clear predictions, fairness, and clinical trust. Um, this ensures clinical trust and ethical longevity. Then for the channels and distribution, the acquisition channels is that we attract users through search engine optimization, webinars, and social media outreaches. Then for delivery channels, the Conceive Score is accessible via the mobile app, the web pages, chatbots, and application program interfaces. Then for partnerships, we plan to collaborate with universities, non-government organizations, and digital literacy campaigns to expand research and engagement. Then for the retention tactics, we want to keep the users engaged with updates, gamified learning, and community support. Then the revenue streams. How do we make the money? This is through the direct revenue models, for example, subscription fees, license fees, and the pay-per-user application program interfaces for clinics and health researchers. Then for indirect revenue models, it's the consulting and data services. Then for the freemium and child access, it's the free basic features and the paid advanced tools. Then the value added streams is sponsored research and branded dashboards. Then for key resources, we need to build and grow. Then for the objective is to build and grow. Then, so human resources, our teams include artificial intelligence engineers, data scientists, user experience designers, and ethics. Then, for the technical infrastructure, we use cloud storage, um, GPUs, Docker, and ML flow. Then, for the data infrastructure, APIs, data lakes, and labeling tools. Then the organizational resources, legal teams and research partners. And then lastly, for the financial resources, we have grants, partnerships, and venture capital. Then for key activities, what do we do to keep the system running? We have the model life cycle activities. We collect the data, train models, test and deploy. Then for the product development activities, we build features, design interfaces, and connect APIs. Then for the operational tasks, we monitor performance and keep the data clean. Then for government and compliance is that to run fairness audits and follow legal rules. Then for customer support, we help users and improve based on the user feedback. Then for key partners who helped us succeed, we have the technology partners where we rely on cloud providers like Amazon Web Services and Google Cloud Platform. Then for data partners, it was the universities, the non-government organizations and government bodies that allowed us access fertility-related datasets. Then for the ethical oversight partners, these are the regulatory agencies and ethics boards. Then the distribution partners is that we work with telecoms, fintech platforms, and e-learning systems to reach users across regions and demographics. Then for the strategic collaborators, um, we have investors and media outlets. Then the cost structure, where the money goes, we have collecting data, cleaning it, storing it. Then for the compute costs, we have the cloud storage, the GPUs, and the bandwidth. Then for the human resource cost, our team includes the AI engineers, data scientists, and user experience designers and experts. These expertise drive development, fairness, and usability. Then for compliance and the legal cost, we invest in data protection and ethical audits, and also the legal certification to meet Uganda's Personal Data Protection Act and international standards. Then for marketing costs, we allocate funds to outreach to campaigns, demo events, and promotional materials to drive in stakeholder engagement. Then for the maintenance costs, we have retraining and scaling the system. Then for governance, ethics, and compliance, um, the governance model, ethics and auditors and technical leads. Then for fairness and bias auditing, we use tools like Fairline and AI Fairness to detect and mitigate bias across demographic groups, ensuring equitable outcomes. Then, for transparency mechanisms, we document our system using model cards and data statements. Then, for explainability tools, we use sharply additive explanations and local interpretable model agnostic explanation to help users and clinicians understand predictions and build trust with us. Then for legal frameworks, we comply with the General Data Protection Regulation and Uganda's Personal Protection Act.